Welcome friends. Today I am going to discuss about the executor service and blocking queue and thread pool which has been used in the executor service. Here you can see that in executor service we have used the blocking queue and the thread pool for the number of thread. And blocking queue, you see that list of the task can be maintained in the blocking queue. And now the question is that why executor service? I can make like a thread, like a new thread or new runnable, and create that thread and execute the run function. There's a drawback for traditional way of creating thread. So the question is that how it will be helpful. Let me check that how traditionally we can create thread. We know Java always run a function asynchronously. So here, if you don't create thread, so we have only one thread, that's the main thread. And if you are creating thread, so just like thread is equal to new thread, and then we are creating another, so main thread, another thread. If you just give that number, so this is the name of the thread, otherwise it's a default will be the thread 0 running main. And the here I have mentioned as the producer is a producer, and the two threads are running asynchronously. And you know that the code of the CPU I can determine runtime, get runtime, available processors. So 4 cores CPU. Okay, so maximum 4 thread can run it here simultaneously. Main and the single thread, how it can make that operation, right? So first, main thread will create a new thread, and it will perform its own operation at some point of time, and it will create a new thread, and it will execute its task, that is run functions, and Java will finally kill that one, and main thread will continue to work on. Okay, and the second thing is that main thread, for I have shown here that earlier that main and one thread, and here main and multiple thread. For if that is the thread creations, if we make it under the loop, so thread creation 5 thread will be created. Okay, under the loop. So thread 0, thread 1, thread 2, so 5 thread will be created if we don't mention the thread name here. Okay, so this way we can create multiple thread and and according to the CPU core availability, so you have the 4 core CPU, so only 4 at a time it can execute it on the part of the 4 CPU. Now the question is that if you have the thousands of tasks, okay, and will you create thousands of threads? Answer is no, because the thread creation is the expensive. Okay, so and if you have the 4 core systems, and number of core you can determine it here this way: runtime, get runtime, dot available processor. So this is not the solution. The solution is that only 4 core is available and 1000 threads, and all the threads will be sitting idle. So it's not a good choice. So creating thousands of threads is not a good choice. We need to use a thread pool concept, right? So let me use that thread pool. Okay, so I have to create the thread pool. I have created thread pool here. From thread pool, say 10 threads, so threads is available, and creating blocking queue. That blocking queue will uh, store the task. Okay, hundreds of tasks, and the hundred of tasks will be stored here in the blocking queue. And the concept of blocking queue: if it is a full, it will not take any more task. If it is empty, no thread will be allowed to take that task. And it's a when the task thread will take that task, it's a thread safe way. You don't need a synchronized way. Okay, so simultaneously it can take it, because this is the features of the blocking queue. It's internally handle, say, that thread safety issue, and it's also making fast. And when you are making that service.execute for loop, this is not a hundreds of threads is created, it's a 100 task is submitting, and the thread pool is the so in the thread pool we got that threads t0 t1. It's a task. In the blocking queue we have the task, and from the thread pool we have the list of the threads, and the list of the threads will make that operation in the 2 step. One is the fetch the next task from the queue and execute it. Once done, and that's a run complete, then it's again going into the thread pool. Okay, so again it's taking the task. So this way it's going on. Now the question is that pool size, right? Number of thread. So number of threads is 10 and the number of tasks is thousands. Okay, submitted. Now the two things, one task is that CPU intensive, one is that IO or the HTTP operations database on the operation systems, other operating system dependent, we need to response. So let me discuss about the CPU intensive, where the algorithm cryptographic operations uh, happens. So they are all that, suppose you have the four core CPU, all the four thread, if you need to create maximum four threads, because maximum, otherwise thread will be idle, because thread creation is expensive, it will consume more memory. So pool size have to make it accordingly. So if you have the four core CPU, you have to make the number of threads in the thread pool is a 4. Okay, if it's a 5 cores n core CPU, it's according to the n core. Okay, and also there is a catch, like if you have the 4 core CPU and all that 4 thread from the thread pool will occupy that all the core, it's not true, because maybe like one of the core is used by the another application, so it might be less. But don't make thread more than core size, so it will not be useful. Thread will be in idle positions, situations in the, if it's the CPU intensive algorithm or any calculation business logic. Okay, but here I am showing that how I can make it. So I calculate the number of core here, and from number of core uh, I pass it here, and thread pool will create accordingly. If it's the 4 core, it will create the executor service with the thread pool is the 4. If it's the 5 or if it's a 10, it's a 10 code. So according to the n code systems, n number of thread will be created. So 4 thread 4 core processor. So this way we can do that. And non CPU intensive operations, we have to make it uh, say 4 core is available, but uh, out of that is the tens of threads are still waiting and the IO operations, so it's a waiting for the response. So there is no threads is available to pick up the task and execute it, so it's a wasting time, right? It's a making idle. So in that case you have to make it some more threads, and the hundreds of threads are it's a trade-off, right? Like rate of task executions and the waiting time. So accordingly you have to make that thread. Okay, so you have to, it's a trade-off, like how many threads you need to make it. Say you have the 4 threads and the like waiting threads is the say 4 or 5, and I can make it 100 threads, and they can, it can continuing operations, so it's not uh, continuously operation is going on. So here I just give it's like a hard coded value 100. You can make it like uh, in the properties file also. This way we can handle with the executor service. And thing is that what is task type is the CPU intensive task type, CPU core count according to, so I have to make that runtime get runtime available processors. So we have to do that, but the catch is that how many other applications executors are running on that same CPU. Okay, and the IO intensive, since we have to according to that that depends on the average waiting time, rate of task execution, trade-off. Too many threads is not good, so we have to make it trade-off high operation. It's not like a 1 lakh 1 crore thread, it's a system will be getting hanged. So accordingly uh, you have to decide that how many thread you need to create. Okay, so this is the overall for the executor service, so which using the blocking queue. Thank you very much.